Hi everyone, welcome to PhDizzle. I'm your host Alice Chang, and today we are interviewing Dr. Promit Ray, who got his PhD in computational chemistry from the University of Bonn and is currently a data engineer at Heartbeat Labs. You have a really interesting story and background. You've kind of been through it all in terms of academia to industry, and you kind of do some side hustles as well. We're going to get into all that, but let's start at the very beginning. So tell me about computational chemistry and what you studied during your PhD.
I studied chemistry right from the time I moved out of school. I did a bachelor's in chemistry, then did a master's in chemistry. And I think it was at the end of my master's that I started figuring out that the lab wasn't really for me. Chemistry is, of course, thought of in the more conventional sense, as being an experimentalist where, you're carrying out reactions in the lab. And this is, of course, the route that I went down as well, only to realize that this was not for me.
Did you ever blow up anything in the lab?
No, I didn't really blow up anything, but that was probably only because we had huge labs and I was always supervised. Okay. Left to myself, I might have actually blown things up, but there were many occasions where things went horribly south because I did not do the right thing at the right time, or did not follow up at the right time, did not show up in the lab at the right time to purify some compound. And I just figured that I'm more interested in actually understanding how things work at a molecular level and, sort of help build algorithms that facilitate this kind of research and support experimentalists instead of being the experimentalist myself.
Yes.
And I think that this became clearer and clearer to me towards the end of my master's, where I actually did my master's thesis in a research group that was exclusively for computational chemistry. And after that, I moved to the University of Bonn, where they had just set up a center for computational chemistry, and decided to pursue my PhD there.
Okay, cool. Yeah. So tell me what your PhD was actually on.
Yeah, you asked me what computational chemistry was, so we start from that and then then move on to my PhD. So computational chemistry is basically chemistry but on a computer. So what one is basically trying to do is to model things at the atomistic level. So these are basically ideals from statistical physics, principles from molecular modeling, from mathematics that are applying to atoms and molecules to predict what is happening at the molecular level. Now, the problem is that the mathematics very quickly becomes complex. So the Schrödinger equation, for instance, could be solved only for very simple systems, and you need numerous approximations and models to actually simulate anything that is of real life significance. And that is where the field becomes really challenging. But as computational power has grown, with the advent of the cloud, people are coming up with more and more ambitious models. The machine learning has added an interesting flavor of its own to computational chemistry. I think there is a lot of interest in guiding experimentalists, help them rationally design molecules, help them rationally design their experiments to achieve materials, molecules, and chemicals with desired properties. And my research was basically focused on trying to understand and trying to guide battery researchers in understanding the processes that go on inside their devices. So we were working with people who were, designing lithium-ion batteries, supercapacitors, and solar cells, and trying to help them optimize electrolytes that would be improvements over what they're currently using. So what we were basically trying to model were the chemical processes that go on when a battery is being charged and discharged, and what affects its efficiency. Or with the huge emphasis that is now placed on sustainable and green chemistry, we were trying to understand what green alternatives could be used in these devices. So from the applications point of view, it focused entirely on electrochemical devices. From a very foundational, a basic point of view, it focused on what's going on at the molecular level in an electrolyte. So atoms, molecules, ions, how they move, what corresponds to what kind of performance, and things like this. At the mathematical and data level, of course, it was a lot of data analysis, it was a lot of programming, and it was a lot of mathematics at the heart of all of these methods, which I really enjoyed. So it was sort of like combining my interest in data with my interest in chemistry, and this is what attracted me to the field.
So you said because you started on the experimental side and you moved into computational, was that difficult? Like, did you have to learn how to code, and like, what was your journey there? If for someone who's like, oh, I do everything on a bench, how do I work with a computer now in the software?
It's an excellent question. I think the transition happened during my master's at a fairly early stage, when I was anyway going through all the courses that would prepare me either for a career as an experimentalist or for a career in computational chemistry. So it was at a point where I had to, kind of diverge a little bit and figure out where I wanted to go. So I did have, the basic training to sort of pursue a career in computational chemistry, but I had to decide. And of course, I had grown up with the image of, doing chemistry in a lab. So doing chemistry on a computer was something that hadn't really caught my fancies when I was a kid. So there was a little bit of a decision that I had to take and decide if, this is something that I really wanted to do. But in terms of training, since it was a very early stage and I did my master's thesis in a computational chemistry group, I was quite familiar with the works already before I started my PhD.
Okay, makes sense. So then you moved from academia into industry. So tell me a little bit about that pivot and why you made that decision.
Absolutely. So I moved to Bonn to do a PhD in computational chemistry, and it was absolutely great. I really enjoyed every minute of it. New country, new group. It was a center just for theoretical chemistry. Some of the most famous names in theoretical chemistry are professors of that department, and I was absolutely thrilled to be there. I was also working with experimentalists who were making cool devices. And so all in all, it seemed very exciting. At some point in my PhD, however, I felt that I was not really having direct impact on people, because the materials we were sampling would never actually make it to the market, simply because they would not be financially sustainable, or simply because they would not feature in what an industry would normally invest in. And this was becoming clearer and clearer to me as my PhD progressed. And as things became harder, this is something that really held me back when I started thinking about my future prospects within the field. At, what is it that matters to me? And I think that kept evolving during my PhD, and I felt that I really needed to have a direct impact on people and see my work having a direct impact on people. And I think the point really got driven home when I went and did an internship in a very famous chemical company here in Germany called BASF. This was an internship during my PhD, where I went and actually saw researchers in industry, saw people working in a chemical industry, and sort of learned that, they have a different focus, they have different success factors, and things work so differently. And when I started putting that in context of what I wanted in my life and what I wanted to see from my research, I realized that I need to make a similar transition to actually, make the most of what I desire for my career. And so I decided that, I should slowly tune my PhD in a way that I can sort of make it more applicable to an industrial career.
Got it. So I want to come back to the marketable skills, but tell me a little bit. So, you joined Heartbeat Labs. So maybe tell us what is Heartbeat Labs, and tell me about data engineering. So how did you transition from chemistry to data, and was that difficult?
Heartbeat Labs is a digital healthcare platform here in Berlin. It's an incubator. So what the company does is that they invest in healthcare ventures that look promising and help scale them up digitally. So the company partners with upcoming ventures, startups that have promise, and help them scale their fullest potential by employing data professionals, marketing professionals, and a whole lot of other professionals. So the company basically functions as an incubator, and then the company's ventures become its partners. So in effect, I work with 6 companies and not one company.
Wow.
So this is a lot of fun, because you're splitting your time between different projects corresponding to different spaces within the healthcare sector. So there is really a lot of exposure. I initially joined the business intelligence team as a business intelligence developer.
Okay.
And the way that transition came about was as organic as it could be. Because my PhD was programming heavy, I quickly realized that I had to employ my programming skills to find something in industry. And this would be the selling point. So I sort of spent some time building a portfolio, taking help from mentors, or putting in some time to get an industry-ready portfolio. And at that point, I realized that I want something on the interface of science and data science. I don't want an application of data science that is non-scientific as my first job. So and obviously, as a chemistry graduate, you would look within the healthcare and the pharma space, and that was one big space where I actively looked, and I found this very promising role in the business intelligence team, where I could sort of, be the intermediary between stakeholders and between the front-end developers, between the programmers, and that was a sort of data science role that I really wanted. And once within the business intelligence team, I of course transitioned into the role of a data engineer within 6 months. What data engineering really entails is making sense of all the data that the company has. And in our case, it makes a lot of sense because it's a company that drives other companies forward using the data that they can collect. So the way you make sense of the data is basically how the businesses evolve. And a data engineer typically is responsible for the entire data pipeline, which is getting the data, processing the data, storing the data, but also doing what a data scientist does on the other end, which is making predictive models, machine learning, and sort of making dashboards, visualizations that would help stakeholders understand what is actually needed or what correlates with a particular observable or an outcome that they might want to see.
Okay, got it. So that's really helpful. And it sounds like there are some pieces that kind of correspond to your PhD in terms of like the software part, or like the computational part, and you were looking at like healthcare/pharma, so kind of the healthcare part and the data part, but it's not directly tied to your PhD, right? So what are some of the other skills, either soft skills or just like even hard skills that you had to learn or that you could transfer over from your PhD to get into the industry?
I think it was the application of some existing skills and some new skills in an entirely new setting. So more than actually picking up skills, I had to change my way of thinking and think more from an industry viewpoint. The way a successful data science project was evaluated was very different from what I had seen in academia. And I think that was actually more of a jump than the raw skills itself.
Okay.
But of course, there were many skills which I had to pick up, particularly with respect to relational databases, because as a data engineer, you're working very closely with the raw data, which I never had to do in academia. So my Postgres skills, for instance, or my SQL skills in general, and just handling databases was something that I almost never did in academia. That is something I had to completely pick up. Working with cloud services is also something that I had to pick up. And then the kind of programs that I now write are very different from the kind of programs I used to write. So those goalposts changed, from academia to industry, and also during the course of the job as well.
You were talking about, you guys, Heartbeat Labs is like almost like an incubator for other companies. So you work for so many different companies. Tech is so hot right now. So what does that mean? Like the tech world, healthcare, startups, what is that? And what part of being a data engineer or on the data side drives success on the tech side?
As with any field, healthcare is just another field where data science would eventually have to percolate. But I think that the company's ideal philosophy and the philosophy of most healthcare companies which are going digital is that conventional healthcare was good and is good on its own, but with data science and AI, it could be just that much better. And I think that is the company's driving force. And coming from the standpoint that I come from an academic setting, I can actually see how a little bit of data science, a little bit of machine learning can actually help biotechnology companies, can help pharma companies, can help a digital midwife. And so for me, it's very important to be able to connect the dots and see how a given a tech effort or a tech flavor would actually add value directly to the business. And in our case, that is very clear. So I can clearly see that, a certain decision, a certain analysis of customer behavior would actually help you figure out what changes are required in an app, what changes are required in your marketing campaign, what changes are required in the lab. For instance, just to give you one example, we have one partner company, which is a biotechnology company trying to build certain kinds of molecules, and they wanted to quickly scrape that, chemical database that we now have to sort of help guide their R&D efforts. This is an excellent application for data science, and this is what we did.
You code, and all these companies, that you're starting are using data, and I assume there's like a front end user experience where people are interacting with the software, but maybe they don't know how to code. And so tell me, I just hear a lot about this phrase called no code. So what is that? Do you guys use that?
There is a huge emphasis now on building products that can be used out of the box, right from machine learning to building websites on your own, to building data science platforms on your own, and pretty much do everything sort of out of the box. I think this is really nice because the idea stems from a desire to sort of democratize this field and make it accessible to everybody. And also eliminate the need for people to hire developers just to have certain tasks done. It sort of gives more control to the founders, to the visionaries, so that they can put their ideas into practice without having to spend so much time on just learning a programming language. And I think that is absolutely great because it allows people to really sort of visualize their final products, work with things and actually see things developing. Because I am also one of those people who actually need to see things to visualize them, and so it is kind of nice if you can drag and drop things and build your own website. I think one very important aspect of these discussions around no code is whether it would make developers extinct or whether it would actually
ask you that. Yeah.
Expect developers to sort of up their game. It's a very debated topic, but I think that it's an opportunity for developers, to get that much better, because behind every no-code product, there is a coder. I mean, no code does not mean no coder. It means that the coder is helping build the product, which is your no-code product, so to speak. And as of now, these products, unfortunately, don't work out of the box. I mean, they will almost never give you the freedom that you would have if you were coding it from scratch. And so if you were to actually build a product that would give you that kind of freedom, that would be a task for a coder to do. And I think there is a huge amount of scope that is actually there in building these apps, building these products to sort of work in a fail-proof way and give the user the flexibility that the said user would have if they were to actually code things from scratch.
Apart from work and what you do professionally, you have a couple of passion projects as well, and very cool that we connected because you also do some science communication. So can you tell me about what you're doing on your own personal time in that area?
Absolutely. I mean, coming from academia, coming from science, I always wanted to keep my connection with science alive. And I thought, what better way to do it than to be in science communication? So at one point of time, I was actually even considering a full-fledged career in science communication. I was looking at, publishing houses, journals to see if they would, have need for a proofreading editor, for somebody, who would be in publishing. But then I realized that this was probably better suited to be a passion project than to be a career in itself, and so I decided to pursue this quite seriously at a semi-career level as a passion project. And as a part of this, I do various things. One, of course, is with Amicable Scientists, where we try to build a multi-author science platform where people can write about their science, where people can communicate, where people can sort of build a community around their interests. And that platform still exists, and we always have a wide variety of researchers writing about their research. I think one of the things that really excite me is to see applications of science where people wouldn't normally look, because you often have applications of science in everything, and a lot of our articles actually highlight applications of chemistry where you wouldn't normally look, or where one wouldn't even think of finding a scientific lesson therein. Often this can be very enticing for members of the public who who need something tangible to make that connection to science. And if you give them that tangible element, they feel very involved. And that is what we try to do with Amicable Scientists. Otherwise, I'm of course a grad who transitioned from grad school into academia, and so it's very important for me to give back to grads and to sort of share my views and also learn from grads who are transitioning, because there's no one way to do it. And the sheer diversity of interest nowadays interests me. And so I also volunteer as an advisor for Free the PhD, for other voluntary programs. I'm also trying to build an education platform to show people that science and data science actually converge. So tech and science are parts of the same story, and I'm doing this with a co-founder who's similarly interested in spreading the word around these topics, and we're in the process of building this. So I think that most of my passion projects actually aim at helping people realize that science is omnipresent, and science and tech are really parts of the same coin, just two sides.
Yeah, I love it. And it sounds like you're doing so much on in this area. Maybe one day it'll become a career. We'll see. Like these things, you never know. But it's good that you have something stable while you work on these things on the side. I know you're pretty busy with your real job and then your passion jobs, but what do you like to do in your remaining spare time, if you have any?
Well, I love music. I used to sing from the time I was a kid. I connect with my music teacher in India, and we have classes every week, weekend
still?
Usually. Yeah, still. We do it
That's
on
awesome.
Skype. Music is very, very close to me. I also volunteer quite a bit. Since I'm in healthcare, I thought it would be really nice if I could, give some of my time to, people actually needing healthcare, but in a slightly different context. So I decided to go to a hospice here, and I spend time with people there. And because it's Germany, you actually require a course to be eligible to go to hospices. So I'm doing a course where they teach you how to talk to people, who are in palliative care, and what you could actually learn from them, and what you could actually communicate about to sort of make the process more bearable. And I've learned so many things about life and about myself in this process that I absolutely enjoy doing this.
That's so beautiful. I love that you do that. So many people volunteer, with kids or whatever, and palliative care is on the other end of that spectrum, but so necessary, where you need people to comfort you, and especially as if you're not if your decision is to be in palliative care, you're nearing end of life, and so it's so nice to have that support.
They seem quite happy and content with the quality of life that is given to them, that the care that they receive, and what they're often looking for is just human companionship, because that is something that they do not get from medical care.
Yeah.
And that is why I thought that this might be some way to actually have a direct impact on people. Yeah. Also, it's interesting that you talked about volunteering with kids, because that indeed was my path into this. I started with kids as well, but at some point I thought that these kids are actually smarter than I am. Look at them dialing in on Zoom, and they seem to know it all. Exactly. And they're super cute, and you can have really nice conversations with them, but eventually they'll figure it out, is the vibe that I got. And so I said that let me also divert my attention.
Yeah. Well, it's it's funny that you say they're looking for human compassion, and we talk a lot about tech and replacing humans, right? And that's kind of nice to be like, okay, there's something that we can still do as humans, and like relating to each other on a personal level that like hopefully a computer cannot replace.
Absolutely. I mean, it's a topic that comes up in almost every machine learning seminar that is meant for a general audience, that what can a human do that a computer can't, and vice versa. Yeah. And I think this entire concept of empathy, about making that one exception, is something that a computer just cannot comprehend. And that is why machine learning can never exist without humans.
One of your hobbies was chess. And I want to talk about that because The Queen's Gambit was on Netflix. So I watched that, and I feel like I remember chess being big when I was a kid and like kind of went away, and now it's like re-emerging now. So tell me about that.
Chess, I think, as a hobby for me was something that came in and out of my life at regular intervals. I started playing when I was a kid, but was never too good at it. And then in my early teens, I think I joined a chess academy and then became quite serious about playing good chess. And I became very interested in computer games where you would play against the computer. And I was very interested in figuring out how the computer would decide its moves and how you could almost never beat the computer. And now, of course, in hindsight, I know about the applications of reinforcement learning and how these chess games are built. And there are very interesting case studies of, how these chess programs analyze games between grandmasters and see what the computer would have done and what did the human do and things like that. But as a teen, it fascinated me. And I think it came back to me again in my PhD when I was really looking to sort of distract myself, mentally reorient myself. That's when I started finding, a chess group. I found like-minded people and I started playing again. Now I'm more interested in it from a professional point of view, from a data science point of view, as in, because it's a game that really lends itself to the programmatic way of thinking.
PhDizzle.
Having fun with smart people who do cool things.